Okay, so if x is 5 on this first one, you got 20 times, 2 rather, 20 times a 2 plus 15. Well, 20 times 2 is 40. 40 plus 15 is 55. Very good. All right, this next one is 15 times a 2, which is 30.
I got 60.
The next one would be 15 times a 2 plus a 30. Well, we just saw that 15 times 2 is 30.
I got 55.
Plus 30 is 60.
On the other one, before he changed.
Okay, on the boxes, we're not going to worry so much about the boxes, okay? Listen, if I bought one fruit smoothie, how much would that be?
250 or 230.
Serena?
Why does she have 2 straws?
I can't see the picture, I can just see this. It's too far away for me to see. Jackson?
$2.50.
$2.50. Excellent. So if, let's say we wanted 4 fruit smoothies, how much would that cost?
$10.
Jackson?
$10.
$10. That's good. What about 10? 10 fruit smoothies. How much money? Quaid?
Is it $50?
No. Sydney?
$25.
25 bucks. Okay. Excellent work. Is this a proportional relationship?
Yes.
Oh yeah, it is. Okay. Think of it like this. If you bought 0 fruit smoothies, how much would it cost?
$0.
$0. So there's the origin. Okay. And if you put this into a table, you'd get the same rate every time. $2.50 per fruit smoothie. So there's your answers. Okay, proportional relationships are going to look something like this most of the time, okay? But there's several different ways you guys can solve these. And here's the first thing you're going to want to do when solving a proportion, okay? And again, this looks like these ones, right? So always start with 2 fraction lines and an equal sign like this. It's an equation. And then you fill in each part, okay? So see how you fill in a number right here. Right here, there's 2 fractions, numerators and denominators. Now, just so you guys know, tops and bottoms, they should have the same labels, kind of like we did when we were converting units, right? So if this is meters and this is seconds, then this should be meters and this is seconds. We're not converting units today, but it's just so you guys know, all right? So let's look at this first one. All right, I'm going to write this down here. 6 over 25 equals D over 30. Well, as it turns out, there's several different ways you can do this, and we'll see the book way, but the way we're going to use is what we call the fish method. And you're going to create a fish with this method. All right? Now to set up fish method, the first thing we need to do is set up our operations. First thing you need to do is multiply. Then after that, you shall divide. And that will equals. Okay? So we need numbers and a letter in all of these, okay? Or letter, whatever. Okay, so the first thing you can do is start with the letter, or the unknown, or the variable, whatever you want to call it, all right? So where is that at? It's the D, right? So we're going to start at D. All right, now you got to go up or down from D. So is there anything above D? No, there's not. So we got to go down. And what number do we have there? 30. Okay. So I'll draw this a little bit bigger. So we went down, right? Then you're going to cross over. You're going to diagonal over to the 6. That's where the next one goes, 6. You see that? All right. Now we're going to come back down like this right here, which is 25. Then we're going to cross back over up here to a D, right? See that D? And then you just solve this, okay? Oh, I know some of you are wondering where the fish is. Well, let's find out, okay?
Is it replace the shower gap? No, no one ever
It's the
replace the shower.
fisherman.
No, we need a name for it. We need a name
The method.
If you do this, you'll find that maybe your fish faces this way, okay? It really doesn't matter, all right? But let us finish. Let's finish this. So 30 times 6 is 180 divided by 25. You're going to get a decimal here, right? Someone with the calculator, 180. Go have a seat. 7.2. All right, so D equals 7.2. I'm going to set this up once again. I need my two fraction lines and my equal sign. I got a 2.5er. I got a 6, an H, and a 9er. Okay. Okay. Well, so again, we got multiplication, and then we're going to divide, and that will equals. All right. So where do we start? H. So we go up or down? Down to an old 9er. There's 9.
Make the line thicker.
Cross over to 2.5. And come back down to old 6. That'll give us H.
There you go, there's my fish.
Yeah. There's your fish.
The answer?
Oh, I don't know what the answer is.
It's 3.75.
3.75? Yes, Cassidy?
What would you do if the H was like where the 9 is and the 9?
Then you would go up.
And then give you the same
Then you diagonal. No. Okay. What does this equal, King?
3.75.
Yeah, 3.75?
Yeah. So would you just write H equals 3.75?
Oh, 5. There you go. Yes, H equals 3.75. Very good. Proportion. Once again, this is how you set it up. You need two fraction lines and an equal sign, okay? Oh, by the way, I should mention this. The reason we need these two fraction lines and the equal sign is because then you have two equal fractions. They're always equivalent, okay? All right, so let's look at this one, all right? So it is in your book, but this one, notice the T is on the bottom. That's one you guys are having questions about, right? So on this, we got to multiply, then divide, right? And that equals, let's fill them in. So you're going to start with,
13.
very good, you go up to 13,
Then go to 2.
diagonal to 2,
That's 23.
divide by the 7, equals T.
26, right?
What is that? I don't know. 26 divided by 7 is 26 sevenths. Yeah, 26 sevenths is acceptable. It can't be simplified. Yeah, there you go.
I got 3.
All right, there you go.
Okay, so you go. Wait. Okay.
Excellent work. All right, good. Questions on this? Quade will do B.
Okay. So this come around and go like that, and then you do 5 times 34 divided by 2 equals y. So 70, so these two are 170 divided by 2 equals y. And then 170 divided by 85 equals y.
Excellent work. All right, so this is good. All right, so Quade showed some good work here. Does it make sense that this is already in the order of operations? So multiply and divide from left to right. Okay, that's excellent. Good job, Quade. Okay, there you go. Okay, well this is excellent. 21 times 7 divided by 3. Good old 49er. Questions? Okay. All right, there's your answers, which you guys got already, so very good. Yeah, be careful. Sometimes the ratio it's going to want compared to the total number of whatever you're comparing to, okay? That way, in that case, you just add, so you get a total, okay? Okay, so recycling. You got 2,000 pounds of paper. It's going to save you 17 trees. How many trees would be saved by recycling 5,000 pounds of paper? Well, we hate trees, so we would not want to save any, right? But
Yes.
in this case, it's theoretical. So let's just save some trees, okay? The concept is still the same though, alright? So let's set up our proportion. What's the first thing that we need? 2 fraction lines and an equal sign, right? Like this, okay? And then, since this is a word problem, we need labels. What are the 2 things we're comparing in this situation here? Quade?
Pounds and trees.
Very good. Pounds and trees, okay? So in the fraction, we're just looking at one of the fractions now. You want pounds on the top or trees?
Oh.
Pounds on the top? Okay, good. Because it doesn't matter as it turns out, so this is trees. Now, if this is the case, the other fraction should have the same units. So pounds on top, trees on the bottom, okay? So let's look. 2,000 pounds. So we're going to write 2,000 pounds. What's its corresponding value for trees? Quade.
17.
17 trees. Very good. Okay. Now we're going to look at this. And how many trees? So this is the one we don't know. We don't know how many trees. But we want to know how many trees for 5,000 pounds. Here we're just going to use old-fashioned fishy method. So let's get to it. You're going to multiply, then you're going to divide, and that's going to equals. So we're going to go up here to 5,000. That's a big number, 5,000. Times old 17. There's a 17. Come up right up here, 2,000. And it'll bring us down to the old X. He says, so what we need is pounds on top and trees on bottom. Okay. Yes, I would have the opposite ones within the same fraction. Okay. There are technically, though, 8 different ways you can set up a proportion. It's going to look different, but you will always get the same answer for those 8 if it's set up correctly. Okay. Because remember, I said we get to choose which one we want on top, and we chose pounds. If I put trees on the top, it would look a little bit different, but it would solve the same way. So let's solve this problem. 5,000 times 17 divided by 2,000 is?
42 and a half.
Alright, so you got 42.5? Is that what everyone got? Alright, now we do need a label because this is a word problem. It's 42 and a half trees, okay? Here's the nice thing about trees, is you either have a tree or you don't. Okay? So can you have half a tree? No, so you'd say you'd have 43 trees.
But what if it's people?
Well, I've never heard of half a person. I've heard of half a brain, but you can't have half a person.
Okay, what?
Alright, Olivia typed 2 pages in 15 minutes. Write an equation relating the number of minutes m to the number of pages p typed. How long will it take her to type 10 pages at this rate, okay? So right now we're not so worried about how long it will take her for the 10 pages. Let's set up the equation, okay? What's the first thing we need when setting up a proportion? 2 fraction lines and an equal sign. Bam! Okay? Next thing you need to do is choose. Let's figure out. What 2 things are we comparing here? Pages and minutes, right? So which one do we want on top? Pages or minutes? Pages. Well, it says to represent pages with P. And then minutes will be represented with M. Alright? So over here, this should be pages. This should be minutes. Oops. Yeah, minutes. There we go. Okay. Now it told us, Olivia typed how many pages? 2 pages in how many minutes? 15. This is the equation. The reason this is an equation, well, technically is because it's got an equal sign. It's got 2 statements on the left and right, okay? But in addition to that, we have 2 unknown values, which is the 2 things we're comparing, pages and minutes. This is the equation, so the next thing we've got to do is consider how many pages, right? So how long will it take her to type 10 pages at this rate? Well, let's set up our proportion. So we've got 2 and 15. And does it tell us the number of pages or minutes? Pages. So how many pages was it? 10 pages is on top, right? 10 pages. There's 2 pages. So what we need to do is figure out how many minutes there are. It will take to type the 10 pages. There it is. It's set up. You're going to solve it the same way. You're going to do some fishy method action. So there you go. There's your fish. There you go. Okay. And what did you guys get? X equals
75 minutes.
That's very good. So you got 1 hour and 15 minutes or 75 minutes. Okay. Please don't convert this into seconds because it's a pain. And my first instinct to see that on the test is just to mark it wrong. So I'm looking for 1 hour and 15 minutes or 75 minutes. Okay. These types of problems. So there's your proportion. Someone give me a number.
74.
74. Someone give me a number.
35.
Another number.
7.
Let's go something convenient like
44.
32.
12.
44.
And over here, let's 44 is big.
2.
7.
4. 4 is good. Give me another number.
7.
Sure.
7.
Let's do x plus 7. Okay. So let's see. Let's go do this. Dang it. Okay. Might have a fraction, but whatever. All right. So this is what you're looking at, right?
Yeah.
Because you were looking at the homework. Well, everything still works the same. Fish.
Oh,
Okay.
it does? Okay.
So multiply, divide equals. So you got 4. Oh, that's a 12. Dang it. There we go. So 12 and a 74. X plus 7. Well, do all this stuff first and then play the switch and stay game. Bam! Done.
Bam. Bam.
You'd get 24 over 37 equals X plus 7. switch and stay game, so you'd have 37s minus 7, but that's going to taste really nasty, okay? Switch and stay game, right? Line through the equal signs, going to bring them down. I'm going to keep my x's on the left, numbers on the right. I got 24 37s. X is going to stay. 7 is going to switch. Bam, subtract.